Hi, my name is Abigail, and this is my Physics 2 Lab 2 magnetic field of a bar magnet. So today in lab, the purpose is to both experimentally and computationally find the magnetic field of a bar magnet. The key physics principle investigated here is the Biot-Savart law, and it goes along with magnetic fields. You can see the different equations that can be derived from the Biot-Savart law, which is the first equation down here, and the other two can be derived from, or in the second one's case, an integral of the first one. And so experimentally, we're going to be looking at magnetic fields and how they correlate to distance. An overview of my results. So first I want to say my initial conditions were Earth's north to south magnetic field was calculated, and when Bx was equal to 0.0017, a meter stick was Tesla, obviously. A meter stick was placed perpendicular to this, creating a straight line along Earth's east to west axis. The system was my phone, which contained the magnetometer. The surroundings were the bar magnet and Earth. Mu was calculated to be 2.0041, and N, which you will see in the experiment section, is negative 2.0876. So for this experiment portion, I'm just going to talk a little bit about what I did in the experiment first. So firstly, we had to calibrate for the Earth's magnetic poles, like I talked about earlier, in the initial conditions part. So we calculated for it in the x-axis and then placed the meter stick along the bottom so the meter stick was facing east-west. And then performed the experiment using a bar magnet at one end of the meter stick and measuring certain distances to Teslas for the magnetic field, which to create this graph. And you can see in the first table on the bottom, you can see the average distance in meters and the average x Tesla, a magnetic field in Teslas, and the natural log of R, the natural log of Bx, which was graphed into the top right graph. And then after that, so this is the on-axis magnetic field. The off-axis field was calculated at the bottom, where you have a distance perpendicular meters, the magnetic field of the y value of the Earth, and then we took the magnetic field in the z to be 0. The distance in meters was calculated here, then the magnetic field in the x measured in Teslas, magnetic field in the y measured in Teslas. Then we corrected it by adding the magnetic field of the Earth to this measurement to get the corrected. Then we have the measured BZ and then the corrected to 0. And then it calculates the net magnetic field just like it calculated the net distance. So for the coding section, you can see in the top right what it looks like when it's ran. In the bottom right, you have the first portion of the code, and on the left-hand side, you have the second portion of the code. On the bottom right, you can see the definition for the function that I use on the left, where we're calculating the function, the magnetic field. We're creating a function to calculate the magnetic field. So on the left, we're calculating the magnetic field in different locations, based on like different observation locations. So observation x1, observation x2, perpendicular 1, perpendicular 2, perpendicular 3, perpendicular 4. And then you make the arrows for them, which you could see in the top right. They're a little bit small, but you can still see them. I probably should have made the scale factor bigger, but I didn't. And yeah, that's the code, and I'm going to also post the code in the comments so you can go look at it. And then this is just the constant of the mu naught over 4 pi. So for what ifs, the first what if is asking, what if we didn't take into consideration Earth's magnetic field? What would happen? And so all of the measurements are going to be off by a specific amount, just like we did in the other part where we had to fix the y values in the off-axis section. We would have to fix the x values for them to be correct. Otherwise, it's going to throw our experimental value very off from the computational values. which they are just off a little bit anyways because of human error, and it could have been errors with the magnetometer and things like that. But this would make it even more off. And so for the second what if you had two identical magnets and stuck them together? Well, it just would have made the magnetic field much larger by some specific constant and throw our data off completely. So, yeah, thank you for watching, and see you next time.